Math 1332, Chapter 7, Consumer Mathematics, Section 6, Mortgages, Video 1, Mortgage Monthly Payment Formula. If you're really paying super close attention, you might notice that I sound or look a little bit different than in the previous videos. That's because the previous videos were recorded over a year ago, and it occurred to me that for the class I'm currently teaching, I did not record videos for this section, so here we go. So what is a mortgage? Well, most people encounter mortgages because a mortgage is a loan used to purchase land, a house, a building, etc. Because remember, the whole idea of installment plans is we need something now, but we can't afford it now. And the person wants to sell it now, but they don't want to just sell it for the face value and take 10, 20, 30 years to receive their money. So an agreement is struck between the buyer and the seller. The buyer agrees to pay out over time with interest, and the seller agrees to relinquish the item up front in exchange for a steady income of cash payments or steady income of payments, and in the long term ends up making more money. But unlike, and this kind of sounds like an annuity, but an annuity is where you throw money into something to grow. But unlike an annuity, instead of saving to grow money into a specific future value, a mortgage starts with a value that you borrow, the mortgage amount. Regular payments, usually monthly, are made to reduce the amount owed. However, within each pay period, interest is calculated and added to the amount owed. At the end of this video, we'll explore this battle, and there's supposed to be another line back here. It disappeared. I'm not sure what the line isn't there, but there should have been a line that said it's almost like there's a battle between the interest, the payments that you pay to pay off the loan, and the interest that's being added. So there's this big pile of money that you owe. You make a payment which takes some off, but then some interest is calculated and sprinkled back on. So it says back and forth until the mortgage is paid off. At the end of this video series, we'll explore this battle between payments and interest and see how early in a mortgage the balance owed goes down slowly, but towards the end the balance drops faster. This is similar to paying off a credit card. If you have a credit card balance and you send a payment, you'll notice that a lot of it goes towards the interest and a little bit of it goes towards the principal. So at the beginning, it goes down real slow, but towards the end, you send the same payment, but the interest is lower, and therefore more of it pays down the balance faster. We'll see that in something called an amortization table at the end of this section. All right. So to calculate a periodic payment for a mortgage, we need 4 pieces of information. Number 1, we need the mortgage amount, which is going to be represented with a capital P. The mortgage amount, and why don't we highlight that just to make it stand out some? The mortgage amount, P. The mortgage amount is how much you have to borrow to purchase the house, the land, whatever. This is similar to principal when borrowing money, hence the variable P. So mortgage is basically how much you have to borrow to get the house or the land or whatever it is. Number 2, we need the interest rate, which is going to be represented with a lowercase r, just like it was before. As before, this is often given as a percent, but should be converted to a decimal when used in the formula. Percents are good for describing things, bad for doing math with. Number 3, the number of payments per year, which is going to be represented with the lowercase n. Now, we've seen the n before when we did compound interest. It was the number of times per year interest was compounded. This is kind of the same thing because our interest is going to be compounded as frequently as we make payments. For example, if you make monthly payments, then n is equal to 12. And if we make monthly payments, then interest is calculated monthly. And the 4th and final thing that we need is the term of the mortgage in years, T. So just like in previous formulas, T is going to represent how long this mortgage lasts. If you have all 4 pieces of this information, then we can calculate the mortgage periodic payment using the mortgage periodic payment formula. And notice I didn't say monthly yet. I said monthly because periodic means with a regular frequency, but that could be monthly, it could be weekly, it could be daily, it could be bi-monthly every 2 months, it could be semi-annually twice a year, It could even be quarterly or even annually or biannually once every 2 years. Most mortgages, however, are done monthly. But if P is the mortgage amount, the principal, R is the interest rate, N is the number of payments per year, T is the number of years, and R is the amount of each payment, which is what we're going to calculate, then the formula to calculate a mortgage payment is R equals, this shouldn't surprise you, a giant fraction. That appears in a lot of these formulas where we borrow or pay off money over time. In the numerator, we have the principal, P, followed by a tall but not very wide set of parentheses, because inside that parentheses is R, little r, over N. And you'll notice there's some very similar, there's some very strong similarities between the structure of this formula and some of our annuity formulas. But in the denominator, things get a little bit different. Open parentheses, the number 1 minus another open parentheses, and inside that parentheses is 1 plus R over N. You see that expression quite a bit in compound interest, annuities, and mortgage formulas. And in the exponent, we have in parentheses negative N times T. We'll close the parentheses on the exponent, make the fraction bar a little bit longer, and then one more set of parentheses to close off the denominator. In reality, this parentheses that it's about to disappear and this one are not normally written in the formula. The reason I include them is for calculator purposes, because if you write the numbers where they belong and type exactly what you see starting at the top, left to right, bottom to, left to right, top to bottom, then your calculator will take care of everything. Excuse me. So this is the formula that you need to know. Sort of. This formula allows us to calculate the payment for any frequency. Monthly, N equals 12. Weekly, N equals 52. Semi-annually, N equals 2, etc. However, all of the mortgage we discuss will have monthly payments, and hence N is equal to 12. Well, if all of our problems are going to have N equals 12, then there's really no need to have the N in the formula when we can just put a 12 there. So if we're doing specifically monthly payments, and again, I believe most, if not all of them will be, then the formula is going to collapse a little. Well, it's not going to collapse, but it's going to lose the N. Our monthly payment, capital R, is still equal to a fraction that has the principal on top, capital P, times R over N, except now N is 12. And in the denominator, open parentheses, 1 minus, open parentheses, 1 plus R over N, but the N is 12 when you're doing monthly, close parentheses, and in the exponent on that is negative NT, except the N is 12, so it will be negative 12T, close the parentheses on the exponent, close parentheses on the denominator. If when you're doing your homework, if you have trouble, if you're in my class currently, if you have trouble putting this into your calculator, please let me know so we can set up a Zoom session and I'll get you straightened out. All right, so this is the formula that we're going to use. If we know the principal, how much we borrow, the interest rate, R, and how long we're going to pay off the mortgage, T, put the numbers in, do the magic in the calculator, and get your monthly payment. We're going to take a look at an example, but this example actually has 4 parts. A house sells for $155,000. Yes, you can find a house for that price if the market is right and the location is right, and hopefully the quality of the house is decent. The buyer makes a 10% down payment. This is common in mortgages because most people who are going to sell you a 6 or 7 figure object like a house isn't going to walk away from the initial transaction with no cash in hand. They want some money up front so that you have something invested already and they've got some money already. And that, of course, is in the form of a down payment. The buyer makes a 10% down payment. A mortgage was secured at 3.5% for 30 years. Find the following. Fix this capital I. A, the down payment, B, the amount of the mortgage, C, the monthly mortgage payment, and D, the total interest paid. Now, if you're thinking the mortgage is $155,000, you are incorrect. The mortgage is what I have to borrow. If I make a 10% down payment, I no longer have to borrow $155,000. So our plan is going to be to find the down payment, 10% of $155,000, find the amount of mortgage, how much more we still need to borrow, and then use the monthly mortgage payment, and then we'll talk about how to find the total interest paid. So let's talk about the down payment. The only thing we know about the down payment is the down payment is 10% of the price of the house. So it's 10% of $155,000. But we've dealt with percents quite a bit. And remember how to find a percent of a number. You turn the percent to a decimal by moving the decimal 2 places to the left. Since the decimal on the 10% is implied to be after the 0, we would move it 2 spaces to the left, and we would have 0.10. Let's go back into the text box. 0.10 of means times, and then 155,000. You can multiply, but a lot of people know that to take 10% of a number, you just move its decimal 1 place to the left, or you can get out a calculator and find out that the down payment is going to be $15,500. Let this sink in. You want to buy this house? Fine. First, give me $15,500. Some people wait a long time to buy a house because they have to save up for the down payment. This is a very common thing. You can get mortgages with 0 down payment, but you usually have to pay a higher interest rate or a longer term. All right, so we're going to start buying this house by first writing a check for $15,500. So what's the amount of the mortgage? Well, the amount of the mortgage is not the cost of the house. A lot of people might think that, but the amount of the mortgage, which is going to be our P, is not $155,000, but it's the cost of the house minus the down payment. I'll get that fixed in just a second. It's the cost of the house minus the down payment. It's how much I have to borrow to buy this house. Well, the house costs $155,000, and we're going to make a 10% down payment, which ends up being $15,500. And now we just got to do the math. I feel kind of silly using a calculator to do the subtraction problem, but I don't want to make a mistake. We still owe $139,500 for this house. That's what we need to finance. That's what we need to borrow. The amount of the mortgage is the cost minus the down payment. Ideally, you want to borrow as little as possible, which means you want to maximize your down payment, pay as much as you can up front. All right. But now we have the missing piece to calculate the monthly payment, because remember, going back not once, not twice, but 3 times, to calculate the monthly mortgage payment, we need the principal, the mortgage, we just calculated that, the interest rate that was given to us, and the term, the number of years, that was also given to us. So let's calculate the monthly mortgage payment. We have a mortgage amount of $139,000. This stylus is not cooperating very well. $139,500. Our interest rate is 3.5%, but as was mentioned before, we're going to convert that to a decimal by moving the decimal 2 places to the left. There is only 1 digit currently to the left. 1 second. There is only, I'm not sure what's going on here. Let me fix that equal sign. All right, we need to turn the decimal to a percent, which means we need to move the decimal. I said that backwards. We need to turn the percent to a decimal, which means we need to move the decimal place 2 places to the left. However, there's only 1 digit, so we have to use a 0. As a decimal, we have 0.035. In our term, T is the number of years that we're going to pay this mortgage out. And that was, I believe, 30 years. Yes, 30 years. And if we were using the periodic payment formula, we would also need N equals 12. But our monthly mortgage payment formula already has the 12 inside of it. All right, so let's substitute the values. In the numerator, we start with the principal, so 139,500. And then we're going to multiply that by the interest rate as a decimal, 0.035, divided by the 12 because we're doing monthly. And in the denominator, we'll have an open parentheses, the number 1, minus another open parentheses and another number 1. The ones don't cancel, by the way, plus the interest rate, 0.035, divided by 12 because it's monthly. Close that parentheses, and in the exponent, negative 12 times the number of years. This is 30 years. Close the parentheses on the exponent, stretch out the fraction bar, close the parentheses on the denominator. Now, for those of you currently taking my online class, on a test, I will ask you to set up the formula and submit that image as part of your work, because it's very easy to put this in a calculator wrong, and as a consequence, you would get no credit for this part of the question. But if you send me the setup, then I can give you partial credit for setting it up correctly. I'm going to call out what I'm typing in. Get my calculator cleared out here. Not sure what's going on in this calculator. There we go. Okay, 139,500 times, open parentheses, 0.035 divided by 12, close parentheses, divided by, for the big fraction bar, now I'm in the denominator, open parentheses, 1 minus, open parentheses, 1 plus, 0.035 divided by 12, close parentheses, exponent button. Now, it's important to point something out, and I'm gonna stop sharing this for a second so I can show it to you. This parentheses around the exponent in front of the negative 12 and after the 30, whether or not you need it really depends on, let me stop the share, really depends upon your calculator. For example, on this one, and I hope it's coming through clearly, I may have to turn off the background on Zoom. But when I press the exponent button, yeah, I'm going to have to turn off the background on Zoom. Give me 1 second to do that, because I want to make sure everybody watching this can see what I'm talking about. Background, none. I'm currently in my office. All right. Let me close this, go back to Zoom. There we go. All right. You may have noticed that in my calculator, right, let me put my finger in the right place, right there where I'm pointing, when I press the exponent button, it actually raises it up in the sky. If your calculator has structures, in other words, stacks fractions vertically or puts exponents in the sky, you can omit some of the parentheses, but it's never wrong to type them when you don't need them. So I'm going to go ahead and type the parentheses there. And I believe we were at negative 12 times 30. And close the parentheses, so that now in my calculator, that entire exponent is up in the sky. Now, here's another thing to be careful of, and I may have mentioned this in a previous video. It's been so long since I recorded them. I am still in the exponent, but if you go and look at the formula that we're setting up, let's go back to the whiteboard. If you go back and look at the formula that I'm setting up, this last parentheses is not in the exponent. So I need to get out of the exponent before I type that last parentheses. This is why you should contact me or somebody when you're trying to put big chunky things in a calculator. How you type it depends upon your calculator. So I'm going to press the right arrow key to get out of the exponent. Notice the cursor drop down. And now I'm going to type the closed parentheses, which is the very last thing I have to type. And I'm going to press equals or enter on this calculator. And I get a monthly payment to the nearest cent of $626.42. 42 because the 7 after the 1 rounds the 1 up to a 2. $626.42. $626.42. Approximately $626.42. And if you're thinking that's a lot to pay each month for a mortgage, it's not. Many mortgages are well over $1,000. If you're frugal and play things out right, you can keep your mortgage payment low. All right, so numbers go into the formula, monthly payment comes out. And let's answer the last question, which is the amount of interest paid. Now, keep in mind that the general idea of interest is the extra that you pay on top of what you borrowed. Interest earned is the total paid minus the amount borrowed. Now, we can either include the down payment in the amount paid, but we shouldn't, because that down payment was never part of the mortgage. That happened before we borrowed any money. So when I say total paid, that does not include the down payment. So let's see if we can figure this out. How much did we pay for this house versus how much did we borrow? Well, what we paid for the house was, the monthly payment is $626.42. I believe that's what it was. Yes. But how many of those payments did we make? Well, we did that once a month. And so times 12 tells us how much we paid each year. But we did this for 30 years. So $626.42, the monthly payment, times 12 gives us our yearly payment, and times 30 gives us our total amount paid. But we borrowed $139,500. So if you figure this out, let's start by figuring out the answer to the multiplication problem. $626.42 times 12 months a year times 30 years. We paid $225,511.20 in payments. We borrowed $139,500. Now I want you to let this sink in for a second. I'll put the cents there just to have the same number of decimal places. We borrowed a little under $140,000. We paid almost $250,000. So how much extra did we pay? Well, if we take the amount that we paid in monthly payments and take away the amount that we borrowed, the difference is $86,011.20. Yes, you paid an extra $866,011.20 for this house. Does it hurt? It does. But you borrowed 6 figures and took 30 years to pay it back. This is the cost of borrowing huge sums of money and taking a long time to pay it back. How could we lower the interest earned? We can lower the term. We could send more than the monthly payment. That's a strategy a lot of people use. Whatever the mortgage payment is each month, they send extra, and they end up paying less in interest. All right, so in the next video, we're going to take a look at another example. I probably could have split this into 2 videos. Sorry, my phone's dinging at me. We probably could have split this into 2 videos, but we'll look at another example. And then after that, we'll talk about something called an amortization table, which shows you how each monthly payment is actually applied, how much of the payment goes to interest, and how much of the payment actually goes towards paying off your mortgage.